Today we have this problem. We have to find the limit of 1 over n times square root of 1 over n plus square root of 2 over n plus dot dot plus square root of n over n. So it's pretty hard for you to get the limit of this thing directly. But guys, I put Dr. Bernard Riemann's picture over here for a purpose because we talked about Riemann's sum yesterday. And this thing really looks like a Riemann sum, right? If we can work backwards from the Riemann sum to the definite integral, then this problem is going to be super easy to solve, right? If you consider this limit of this whole thing as the integral from 0 to 1 of the function square root of x with respect to derivative of x, and this thing is going to be equal to this thing. So working backwards is a little mind bending. Let's just work from this thing forward to the limit. We learned about the Riemann sum actually. So if we divide this function, so basically this function square root of x looks like this, right? So if we divide it into different rectangles, as we talked about with the same base down there, right? And then we divide from here from 0 to 1 into n equal based rectangles. Then the area of this part can be expressed as 1 over n times square root of 1 over n plus 1 over n times square root of 2 over n, right? Because the function is square root of x. And the value over here is 1 over n. The value over here is 2 over n. And the value over here is 3 over n, and so on. And then if you work down, you get 1 over n times square root of n over n, which is exactly this thing over here, right? And the area of the shape is also exactly the integral of square root of x from 0 to 1. So now we have proved these two things are equal. Okay, so now the problem becomes, how do we find the value of a certain integral? Actually, there's a formula which makes things pretty convenient. The formula says if you have a definite integral fx from a to b, and then this value is equal to big F of b subtracted by big F of a. So let's underline this formula over here to make it clear. Maybe we should get a blue color here to make it stand out. Big F of x actually is the antiderivative of fx. That means the little f of x is a derivative of the big F of x. All right, just work your mind around this. So the integral of square root of x from 0 to 1 is equal to the big F1 subtracted by big F0. We only need to find the big fx for square root x, right? Pretty easy for you to get fx is equal to 2 over 3 times x 3 over 2. All right, so now let's put this function back in here to find the value. So the original integral over here is equal to 2 over 3. And this is the value of the integral, which literally is a value of this limit. See you guys next time. Take care.